Cool. Okay, hi. Thanks for coming. This is the April edition of the DigitalOcean Amsterdam Meetup here at Your Majesty Amsterdam. Hopefully you managed to find a beverage. It looks like most of you did. And somewhere to perch yourself, which is good. Yeah, just for information, like toilets are right behind you. If you smoke/vape, if you can do it outside, that way you came in, that'd be amazing. We got a table of stickers, which I see a few of you have attacked, which is good news, because I have so many. Yeah, and yeah, you can always bring your own, like for next month if you fancy contributing. The Wi-Fi is Your Majesty Guest, and the password is Cavalier. And if you fancy tweeting, you can always use the DO Meetup hashtag. That'd be great. Try this. Yes, so this meetup is made possible by a few people. Hopefully you saw Sharon on the way in, and she got your name and gave you a name badge. Yes, in case you've forgotten what she looks like, there she is in black and white. She'll be playing around all evening. If you have any questions, you can always ask her, myself, or any of the YM team. They're about. And then, yeah, Hugo helped me set up the live stream, organize the room, and just generally get everything sorted. So I'm massively grateful for that. And then, yeah, thank you all for turning up. It's massively appreciated. Yeah, there's like 3 other massive meetups tonight, so I'm glad you chose this one. Yeah. And then, yeah, so here's the agenda. Yeah, we've done the first one. This is the introduction to the meetup. We got 2 speakers tonight. Alex will start the night off telling us about how you can read people's minds using JavaScript. That's the general premise?
Kinda.
Yeah. Then we'll have a brief interlude. It means you can grab another beer, more wine, go to the toilet. And then when we come back, Hugo will give a chat about NodeJS and how he used it to make useful machines. Pizzas hopefully will turn up roughly around 8:45, so 8:45. And yeah, there will be plenty of beers for people to sip on in the meantime. So yeah, emergencies, just in case. Yeah, if there's a fire, there's fire exits, that one there, this one where you came in. You probably should use that one, otherwise you have to like climb over my wetsuit and all the beer crates. So yeah, use this one. Go downstairs and you go assemble across the road. Hopefully we won't have to do that. If you somehow injure yourself, like chop your arm off with a beer bottle, I don't know. Yeah, myself or one of the Majesty team will sort you out, give you some paracetamol, wrap you up. Yeah, hopefully we won't have to do that, but you never know. So yes, don't panic. We've got it covered. We have a code of conduct. A few people asked why we do this. Put simply, it just outlines how everyone should behave. You know, and the protocols in place just in case there is an incident. It's just good practice, like conferences have it, so yeah, we've got one too. Basically says, if you can't read at the back, DigitalOcean is dedicated to providing a harassment-free event experience for everyone, regardless of gender, gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion, and technical choices. It's, yeah, just treat everyone nicely like you would yourself, and yeah, it'll be fine. There's a full version of this on the Meetup page, and by being here you're kind of adhering by it, so yes. Yeah, if there is an incident, you can either find me or you can send me an email or a tweet, depending on how private you want to make it. You can also contact Samantha, who she organizes the DigitalOcean meetups globally, and all the details will be on like the feedback slide. Yep, and then we have sponsors. So we have Your Majesty and DigitalOcean sponsor the event. Yeah, DigitalOcean, in case you didn't know, they're the first all solid-state cloud hosting provider. You can set up a droplet in a record 55 seconds, and it looks something like this. Yes, and it has full root access, so it really is the bee's knees. These guys paid for all the beers, wine, pizza, and they give us all the swag, so we're massively grateful for that. Yes, and it's all super simple, so you spend less time doing this and more time like doing stuff you want to do. And then, yeah, as I say, we're at the Your Majesty office. We are a design and technology firm. We use nice, like, tall serif fonts. We're all old-fashioned. Yeah, and we do digital product and brand experiences for companies you might have heard of. But what does this mean? So, you can see it, that's great. We put NMDs, which are shoes, on the side of massive cubes, and then we put these in cities all across Europe, and they look like that. That was for Adidas. We did an award-winning 3D horsey game built in WebGL, just because we can. Yeah. And we also do loads of stuff for Samsung SmartThings, including the Samsung SmartThings website. This is actually part of an instructional video that we put on Samsung Smart TVs, all of them worldwide. So if you buy a TV, this will probably be on it, and it tells you how to like make it smart. If you want to know more stuff about like what we do, you can always find like Hugo, myself. There's Casper at the back. Yeah, we will happily tell you more of the stuff we do. And yeah, that's it. I'm not going to go through the stack and say we use like JavaScript and Docker. You don't need to know that, but you can if you want. If you want to know, we can talk it. Yeah, and then the calendar. So hopefully they're going to do some more meetups in the future. We typically do them on the third Wednesday or Thursday of every month. So what May is the exception to this, because I wanted to take advantage of the CodeMotion conference. The talks are generally centered around like web development, DevOps in the cloud, essentially nerdy stuff. Yeah, so like next month we've got Phil Nash from Twilio talking about the JavaScript web token. Ben, I'm going to pronounce this wrong, Straub from Zendesk talking about hacking culture of JavaScript, and then maybe Simon Bennett from Mozilla talking about security testing with OWASP ZAP in continuous integration and continuous development. He might come, maybe, if his like schedule allows. Then in June, Melanie Ryback from Radically Open Security is talking about pen testing and chat ops. I'm going to try and do another security speaker. That will really hopefully be interesting. And then in July, we've got Maurice Zian from Bol.com talking about resilience engineering in a microservice landscape. We're pairing them with Daniel, again, the names, Gelber, and again, SJ, Stuart Cranen from Picnic. These are like, in English, you never have an S and a J. Anyhow, and they're doing mesoservices, architecture for optimal trade-off between engineering and operations efficiency. So it's kind of like microservices based. So that's July. We've got a few other things in the air for like August, potentially having speakers from like GitHub to talk about Git things. I'm trying to get hold of people from the Amsterdam Internet Exchange. So that's one of the largest internet exchanges in the world, and they're just down the road. So to give us a talk about how the internet actually works. So yeah, if I can get one of those in, that'll be amazing. And I'd like to get someone in from Equinix, who runs the Amsterdam data centers, and that's where DigitalOcean is served. So if you're on like AMS 1, 2, or 3, that's where it is. So if I can get somebody in, they will be here. Yeah, so hopefully there's a few things that you might be interested in and might see you next month. That'd be great. And yeah, so this is me in sunglasses. There is my Twitter thing if you want to like send messages. There is Samantha. She runs the global DigitalOcean meetup stuff. So you can send feedback or incidents or more or less anything, questions to her, or you can. There's her email address, samantha@digitalocean.com. And yeah, once again, if you want to hashtag, send some messages, it's DO Meetup. And that is more or less me sorted. Yeah. Does anybody have any questions? Doesn't look like it. That is good news. Okay, cool. Well, yeah, I'm going to hand the floor over to Alex. He has flown all the way from San Francisco to be here, and I'm super grateful. And yeah, I'm going to talk about brain stuff with JavaScript. Cool. Thanks. If you give them a warm welcome.
I think we can just switch this off.
Yeah.
How's everyone doing? Awesome. Thank you, David, for the introduction. Can everyone hear me fine?
No,
That's not what I prepared.
The tricky nice animation.
this is so funny.
Yeah. So check this.
Yeah, hang on.
Well, you fix that. So today is my first day in Amsterdam. As David mentioned, I flew from San Francisco. So right now my time there would be 10 a.m. I will be having my first cup of coffee, but it's 7 p.m. here. I had 4 coffees, 2 beers, so this is gonna be fun. Thank you.
Hang on. It's,
I'll continue. So, I work for Netflix. I work for the Netflix partner platform on the applications team. So, my job is to help Netflix get to all the devices. And I do this by creating tools that allow the organization to scale as far as devices is concerned. So we have an application where all the new devices, meaning the new Samsung TVs, the new game consoles, and all the devices, which are thousands, are run Netflix, are registered and are set up for certification. What the certification means? Certification means that the device actually has all the right implementations in order to run Netflix the right way, in a way that it performs. So there's a team at Netflix that they basically creates this SDK. There's a team that works with the partner to install this SDK, and my team supports the scaling part of the organization. We manage the devices, and we have a bunch of other tools that we create in order to basically streamline this process that could take anywhere from like 3 to 9 months. Great.
yeah, okay. Well,
I'll keep going. So
We're going to turn off the projector because the stream seems to be fine.
I'll just unplug and plug it in. Whenever something doesn't work, I usually restart my computer 3 times. That fixes it, but hopefully I don't have to restart.
oh, we just went through this and we knew it was working. Yeah.
Yeah.
Of course. It
Do you
doesn't
mind
work.
pressing just more buttons?
What? Hang on. Let's see if it works now. Come on. Oh my God. What is
Wait,
that?
wait.
Why is it green? It was just working.
I'm going to do the Nintendo trick. What is NeuroJavaScript? NeuroJavaScript is basically combining the JavaScript stack with Neurotechnology. And we do this by using hardware that have biosensors to measure electrical activity in our bodies, and then work with that data in order to do applications and to help understand more humans and why we do the things that we do.
Anything's wrong? No?
No.
It's definitely a projector.
It seems to be perfect.
All the things that we do actually happens, they're all coming from our brains. In our brains, within our brains, we have millions and millions of neurons. And neurons happen to be the core component of the brain, and they actually communicate with each other. Think of it as like a pops up design pattern where they are sending and receiving messages. But each time they send and receive messages, they're actually creating electrical impulses. So there's tons of volts going up in and down in range from negative and positive energy, depending on how we trigger things within our brains, right? And I don't know if it takes you back to school when you were learning about the human body and the brain and neurons and cells. But when it comes down to is that nowadays we have access to technology that is actually very affordable. Technology that allows us to capture this energy. And so it happens that now JavaScript, the most accessible language in the world, can get access to this. And you, as a JavaScript developer, as a web developer with your current skills, could actually tap into that ocean of electricity, right? With the skills that you have, JavaScript, and you're able to actually do a lot of very cool stuff. And I'm here today to show you how to do some of this. So I mentioned biosignals, right? And what are biosignals? Biosignals is actually cover a whole category of different types of signals. Woo! Thank you. Let's give it up for Hugo and David. So electrical biosignals may include EEG. How many of you are familiar with what EEG is? Awesome, a very good amount. So EEG basically stands for electroencephalogram, and it's pretty much the way that we can capture electrical signals or biosignals from our brain. We also have EMG that does this but for the muscles. We also have ECG, that is electrocardiogram for the heart. And then we also have EOG for the eyes, and then we have many other types of biosignals. The reason why I mention this is because this opens a whole new world of possibilities when it comes to like technology. And if you are super curious about the new technologies and everything that is possible nowadays, you're going to find yourself being able to work on like many different areas within technology, including JavaScript on the front end and on the back end, doing data visualization, having to tackle problems that are related to communication between server and the client, because once you send that hardware is captured by Node and you need to send it to the client, to the browser, so you can do something with it, which includes also potentially using machine learning or neural networks to make sense of the data that you're using. But then you were talking about hardware, so there could be Wi-Fi and Bluetooth protocols that you have to deal with, with JavaScript. You get into design patterns that are complex, that will help you work better with this type of data, like reactive programming and observables or streams. And then you have the actual different type of hardware, like brain-computer interfaces, armbands like the one I'm using today, and many other things. So there's an infinite ocean of possibilities when it comes to what you want to focus in when it comes to working with biosignals. And this is why I want to talk to you a little bit about OpenBCI, because OpenBCI is an open source brain-computer interface that I've been using. That is actually both open source in hardware and software. So OpenBCI, based in Brooklyn, have open source all of their work that basically allow you to, at an affordable price, buy a board, microcontroller that is designed to capture EEG signals, and they allow you to pretty much print out yourself or 3D print your headset at home. And basically something that a few years ago you would have paid maybe $30,000, now you can get access within a few $100. And what is so cool about this is that, well, for example, this is the one that I own. I have it back home. I don't have here today with me. Today we're going to be more simulating, but I'm going to be giving you a live demo of actual biosignals coming from this armband. So how many of you are familiar with Stranger Things? So if you remember what Eleven was wearing, we're talking about the same thing. We're talking about an EEG headset. We're talking about capturing electrical impulses from the brain. And you could actually see in some of the episodes where that signal was like going up and down depending on like how worked up she was. You would get different artifacts from there. So yes, you can use JavaScript to do the type of things that they were doing to 11. Not really, but let's talk a little bit about the way this is actually getting into your hands. Like, how are you getting into that data, right? It could seem far-fetched when you have this hardware here in the real world, and then you're programming your code and you're actually working with real data. So with the headset, using Bluetooth, it could connect to a dongle, which could be connected to the computer, but that is an optional step. actually the headset can talk directly via Bluetooth to your computer. So you could use your computer and Node to capture, or actually the browser, to capture this data via Bluetooth. Then after you have it in your computer, you would process it either in Node or in the browser. And ultimately, you can do something with this data in the browser using JavaScript. And that involves being able to do WebGL, Canvas, zone manipulation, SVG, framework of your preference, whatever you want with this data. We're going to be talking about what having this data means actually. So this is just a basic diagram of the communication. Actually pretty simple. It's mostly hardware that communicates via Bluetooth, and ultimately you can capture it in Node or JavaScript in the browser. So what I've done in the past year is that I've been dedicating my free time to this community called NeuroJavaScript, where myself and other people interested in this type of research can go and collaborate. And we're trying to grow this to a set of APIs or tools or data visualizations that help other people accomplish what they're trying to do. And let me give you an example. I have people reach out to me from hospitals and people that are working, doctors that are working with EEG for like many years, because EEG is a technology that has existed for at least, I don't know, 30 years maybe. In order to, let's say, validate that when in surgery, if using actual sensors, the same type of sensor that you would have in your head, if you have it around the eyes while you're doing performing eye surgery, you could use one of the open source projects that visualizes that data, and you could see the feedback whether or not that surgery is actually affecting the nerves, right? So that could be potentially saving people's lives. And moreover, what I've done is that I'm trying to simplify this API so that with a few lines of code, you can actually get to the fun parts. You don't have to figure out how do I do the Bluetooth communication, when I get it, how do I parse it, and all this. I'm trying to simplify it with something called OpenBCI RX, which takes the OpenBCI SDK and makes it reactive. How many of you are familiar with reactive programming here? Great. So I'm going to give a very, very brief crash course on reactive programming based on RxJS, reactive extensions for JavaScript. So just bear with me. So RxJS is basically a way for us to deal with asynchronous data. Some people call it the Lodash for events. So basically utilities. So in a world where we're dealing with many asynchronous issues and we have to deal with real-time data, this set of tools are going to help you use the right design patterns for you to accomplish your goals without having a lot of boilerplate code. So RxJS pretty much combines the iterator and observer patterns that you might have used before, and then it takes the best parts of functional programming into a collection of tools. So for example, here, if we have a button, which is a DOM element, and we attach an event listener for a click handler, so we can console log whenever there is a mouse click happened. This is the way we would do it imperatively, right? This is the way we're used to doing it, pretty straightforward. If we want to make this reactive, the button would remain the same, but instead of attaching an event listener, we would use RxJS observable class, and we would pretty much create an observable from an event. An event takes basically an element and takes an event, for example. And the same way you would pass a callback here, you would just use the .subscribe method, which would do the same thing. So this code is actually doing exactly the same thing as the one previously. So why are we learning a new way to start working with reactive programming? Because from now on, anything else that you want to do, it just becomes very, very easy. For example, reactive programming or RxJS was designed so it's chainable. So even before I execute the .subscribe call, I could start adding method. And there are dozens and dozens of methods. Just like you would have a .filter in an array prototype or a .map, you have those type of operators, which are basically just functions, to transform this data. But just make sure when you think about this data, we're talking about collections of values over time. And this is pretty much when RxJS is very powerful, because it adds that time dimension. And I'm going to give you an example so it becomes a little bit more clear why working with Brainwaves makes more sense when you're doing it with the observable pattern. So we're going to be very briefly reading some Brainwaves with OpenBCI RX. It is as easy as doing an npm install OpenBCI RX. Basically, you add your dependency to your package.json. And then what you can do is that you can require OpenBCI RX. And what this gives you is actually two classes, right? And Cyton and Ganglion, they don't make much sense without context. But what these things are just the type of the board that you're using in the hardware. Because as in software, right, you bump minor version, major versions. In hardware, you have to create different hardware with different specs. So think about, let's say, Cyton as a different version than Ganglion, and they might work a little differently. Maybe Ganglion is the one that supports Bluetooth. Maybe Cyton is the one that could support Wi-Fi. So as far as you know, after you get the hardware, you will know which one to use, and you can just take it from there. My preferred way of creating a brain observable is to just creating a variable, call it brain observable, and then it will be equal to the board that I'm using. In this case, would be the Ganglion, which is the one that supports the Bluetooth, right? And now brain observable. Yeah, so this is the board type. And now brain observable becomes this observable that is basically the same observable from RxJS, but with operators that are designed to work with EEG and brainwaves. So a very simple use is that you would just call you would use the class, you would call it, and then you would subscribe to it. And then you would get a callback. And that callback is going to contain a sample. And we're just going to log that sample. But what is a sample? A sample is pretty much 1 unit of data. Let's talk about samples, and I'll go back to simulate. And a sample looks like this. Example is an object that contains many properties, including the sample number, but what we really care about the most is channel data, because channel data is the brainwaves, which is represented as an array with the length of the number of channels of your hardware. So if I have a headset with 8 channels, I would get an array with 8 values. So you can see how you have channel 1, 2 until 8, and each one of those is going to give you a unit in volts. And I know that working in volts can be something new to you. At the end of the day, it's just a number. So bear with me, and I'll show you what you can do with those volts coming from your brain. But it's super important to know that you're going to be getting a sample. Where's the slide? Every 4 milliseconds, right? So given that 1 second contains 1,000 milliseconds, and you're getting 1 sample every 4 milliseconds, it's pretty fast, right? That would make a rate of, there's the slide. That would make a sample rate of 250 hertz, which means it's going to give you 250 samples for each second. So each second you're going to get, here it is, you're going to get 250 of this. And now start thinking about, in a world of JavaScript, we're using callbacks, right? Getting that amount of data at that sample rate and wanting to do something with it in real time, it is a challenge. This is when reactive programming comes into play, and I'll show you why. One of the reasons is that volts on their own, they don't mean too much. We need to convert it to another type of measurement that we could use. For example, frequencies. Our brainwaves can be manifested in frequencies the same way music can be manifested in frequencies. So if any of you are familiar with the fast Fourier transform algorithm, this pretty much takes those volts or microvolts or whatever measurement, and they convert that to a frequency. And frequencies are very important because through research we found that there are different type of frequency bands: alpha, beta, theta, gamma, and all of these bands, they actually map to different type of cognitive information that you might want to know. For example, it is known that theta frequency range is used to measure your relaxation state. So people who do yoga, for example, can see if they have done progress or not, given how low or high their theta waves are. This is why it's important to be able to convert those things. So with OpenBCI RX, it's pretty simple. Instead of having few functions or dozens of functions and tons of lines of code, we'd abstracted all this out, things that you would do very often, into just a few operators. So if you take this part here, the rest remain unchanged. We have a brainwave observable, we have a subscribe method, but if we start chaining operators, which is when RxJS actually becomes very, very useful, then you can see how you can convert to different units, how you can create a buffer, meaning a group of items, or in this case samples, and then you can start converting to frequencies. Great. Any questions so far? All right. I wanted to take a second and point out that the brain observable actually takes a parameter, which is an options parameter, which can contain a simulate property. And basically, if you set this property to true, instead of the library trying to read from your actual hardware, it would just start simulating data that is human-like. This way, if you want to get started, you can start working with simulated data until you get a headset, if you decide to do so. So there are like no blockers, so because hardware shouldn't be blocking us. Now, if you really want to conduct actual experiments, like I've done before, you do need the hardware. I do not recommend any experiments that include like measuring hunger. You'll get very hungry very fast, believe me. All right, so let me just show you how simulating brainwaves looks like. I'm going to switch to my terminal real quick. And I am going to, this is so small. There you go. I'm going to run a basic example, the first one that I showed you, and this one actually shows you the 250 hertz. So basically 250 samples per second. And this is how it looks. It actually be faster than your eyes can actually perceive, but that's totally fine. As you can see here, the count keeps increasing. At this point we're like in the 3000s, right? And then you can actually get some raw packets and bytes. So this is what you get out of the box just by like 3 lines of code with OpenBCI RX. If we're talking about frequency, and we took the second example when we do 2 microvolts, buffer count, buffer to FFT, it would look like this. The data structure changes because we're talking about 8 channels, and we are buffering, let's say, 256 samples, which means we're buffering for around a second and change worth of data, because to apply a frequency algorithm, you need to have certain amount of data. The good thing is that this actually starts windowing the data and after a certain amount of time, you start getting the data just basically with the next, let's say 10 samples, for example, in a faster rate. So to show you this, because we're getting data every like second, if I go to my example of FFT and I change so it actually windows every 10 samples, I don't know if you can see that. You can see how the first one takes a second, and after that it's pretty real time, really fast. So we have a 2D array, an array with 8 arrays. Each array is a channel without buffer. Alright, so that is like simulated brainwaves. There's so much you can do with it. In this talk, since I have actual hardware, I want to focus more on the Mayo armband. How many of you have heard of the Mayo armband before? Cool. Alright, so remember when we were talking about biosignals and I mentioned EEG and then EMG? This is EMG. Basically, this captures muscular data, and it basically does it with some sensors that are in each one of these rectangles here. And this is actually doing the same thing as the OpenBCI. It's transmitting via Bluetooth, and I actually have a little blue USB dongle here that is capturing that. But all the code that I'm going to show you from now on is actually just client-side JavaScript. So I created a repo, an open source repo, where I have the code that I'm showing you today, because I want that if you're curious, you should be able to go to GitHub and just run it yourself and play with it. With no further ado, let's just biosense. Alright, so I have 2 experiments here. One is called a slider. So basically, this is just taking the data based on EMG and the accelerometer, and then it's just parsing a value to a slider of an HTML5 native progress element. It's just a few lines of code, and I'm going to show it to you. That is like what I could do in like under an hour, just experimenting real quick. You can take it to another level. For example, if you're crazy about coffee, you can connect this to your coffee machine and say, "Give me coffee," and then it will maybe give you coffee. I don't know. All right. So the next example, I really like. I call it spoken pose. This is native JavaScript node library, just in Mayo. So what I'm going to do is that I'm going to do like around like 5 poses. One of them is a fist. Actually, this takes like a few seconds to start working. So let's give it a second. Is the sound? Oh,
Should be on.
all right. So let's try one more time. I'm going to make a fist, then I'm going to either wave in, wave out. I'm going to start to double tap, and we're going to see if this armband actually captures those poses. Did I hear something?
I'm not sure.
Okay. Maya, don't embarrass me. All right. Let me refresh.
Maybe you want to try your...
So I feel it vibrating because when I start the app, I just send a signal to vibrate the armband. Let me see if you can hear it.
Yep.
Okay. So let me give it a couple of seconds. I don't know, man.
Oh, maybe you're connected to...
Just,
I think the audio disconnected when we disconnected the...
oh, how dare you. Okay.
So if we go to...
I've been like doing poses this whole time here. Okay.
yeah, so here, headphones.
Oh, man.
There we go.
All right.
Let's try that again.
So it should work now?
It should.
So you're killing me right now.
Is your audio?
Yeah, it should be on.
Yeah, let's try without this.
Oh, without that?
Let's see what...
Well, HDMI takes over, right?
Yeah, let's try again with this. Where's your preferences again? Can you go to audio sensors?
I'm getting tired of making fists here.
Man, this is
All right, so
yeah, sound,
sound,
internal speakers.
internal speakers.
Should have some sound now.
You should? Are you sure?
I will.
Jesus
Are you
Christ.
playing the sound through the browser?
Yeah.
I see there's the little speaker icon on the tab bar, so maybe the browser is not receiving the signal.
No. I already gave it permission. It should be fine, I think. But it's not for you to point it out. Do you see something there that I'm not seeing?
No, there's nothing there.
If the tab plays any sound, there should be a little speaker
There's
icon.
It should be a little
Yeah,
speaker
yeah,
icon.
yeah.
Yeah, that's true.
But it's not there.
Oh, I see. There should be an indicator.
Indicator.
Yeah, so
Finger spread.
Oh, there we go.
Okay.
Maybe the fist.
Hold on.
Wave out. Wave in. Fist.
There we go.
Wave out.
It's doing all the things that I was doing previously. I think it's kind of like out of sync.
Okay.
It's catching up.
Wave in.
Come on, man.
Wave in.
We
Fist.
just did this.
Finger spread. Double tap. Finger spread.
Actually, it's like this. I felt the vibration there. You lazy browser, come on. Alright, let me refresh it one more time. I felt the vibration there. Alright, let's give it another try. I think it's tired. I don't know. He was just working, I swear.
It did work.
All right, let me show you the code and I'll come back to this. So what I'm doing here, very similarly, I'm using RxJS. I don't have a library that wraps Mayo. I'm just going to show you creating a simple observable. And in this case, we're requiring the observable from RxJS, that class, and we're requiring the Mayo class from Mayo API. We're just gonna listen to the connected, and we're going to vibrate, so you know when your app is running, it should vibrate for a little bit here, like the actual armband. Then we're gonna just invoke or execute the stream EMG, which is the type of data that I'm interested in. We're going to create a variable called a pose. The $sign at the end of the pose is just a naming convention for an observable type of variable. And we're going to do observable.create, and we're going to have, which gives us fSubscriber function or object. And then whenever there's a post detected by the Mayo API, we're going to basically just call the next on the subscriber with the post name. This basically just makes callbacks work as an observable. So basically makes it easy to work with data over time. And then we have a speak function, which uses the speech synthesis API, but it's native to the browser. And then we do a new speech synthesis utterance, and we pass the text, right? The text is the text that Maya gives us whenever the post fires. It gives us the post name, and we're passing that, right? So we get the post name here. I'm just calling it text. And we're passing it to the native API, and then we're just doing synth.speech. We pass the speech variable, and that is what creates the sound. So basically, text to speech in JavaScript takes just 3 lines here, if you didn't know. Ultimately, whenever we subscribe, we just call that function that I just showed you with the post name, and we connect to the Mayo with whatever namespace you want to choose. That's the one that I chose. All right, let's see if we woke up already or not. Jesus, man, technology, I swear. Everything is failing, like the projector, the Mayo. It's just like Murphy's Law right here. All right, so.
Maybe restart the browser for good measure.
Oh, all right. So.
Let's try it.
To try Internet Explorer.
Oh man, you didn't say that. You did not say that. I didn't come all the way here to. No.
Restart the computer.
3 times, right? All right. Anyways, this is going to restart, and we're going to give it another try. But in the meantime, let me just give you a little summary. If there's something that I want to leave you with today, is that you can use your skills to start doing very incredible, amazing stuff. I'm trying to make it so people don't see this as intimidating as it was to me when I started. It's been a whole year making progress on my free time, just for the fun of it, just to learn, just to see what happens, right? And I've already gotten, people have contacted me from hospital and saying that this is great, we didn't know we could get Brainwaves to the browser. So if you think about it, we have amazing doctors in this world, and we have amazing programmers, and there is a gap, right? And if you think about it, if doctors could just code it away, they would. If we knew all the science, we would do it. Turns out the science is not too bad whenever you start, small. So you could be the one actually coming up with the next thing that could actually impact human lives and making a change, right? You already have the skills. The only thing that would be missing is like interest or passion. So that's why I created the NeuroJavaScript community. So check it out. It's on GitHub. I'm gonna give you my contact information if you're interested. But I hope that you found this useful, and thank you.
Waving, double tap, waving, double tap.
Oh, chill. No one likes no one likes being told what to do, right? So I'm just gonna leave it here. I'm gonna show you my own time, but I'm just gonna leave you with this slide. This is something someone did, just hacking away with the OpenBCI headset, and as you can see here, there's already people that are able to control their wheelchairs with EEG with a headset. This is possible because of programmers, people just like you and me. So yeah, cool. Thank you.
Cool, that was really interesting. Does anybody have any questions? Alex has
Yeah,
to
questions.
step off, so.
You in the back. You're very tall.
Very cool talk.
Thank you.
So for the Mayo, I guess the poses are configured in maybe a separate program, like FIS or Wave thing?
Yeah, so Mayo has their own API, which is a JavaScript package, npm style Mayo, and it comes with a hook to a pose that they already predefined in their library, and those are like 5 or so.
And for the EEG, like the helmet, do you also have like libraries?
No, that's what I'm trying to do.
Okay.
I am trying to abstract that out, and let's see, like on yawn, do something on hunger, like anything that is like the humans do, anything that you can think of that could be an API, right?
Yeah. Okay.
Of course, try not to get too creepy, invasive on human beings, right? Just just like unemotional love or whatever. Who knows? Questions? Yes.
How did you first get into this?
How did I first get into this? So I've been working in open source for a while now, and I've been doing different stuff. And then I was talking to a friend of mine that we developed a product together several years ago, and then he started working on this with someone else. So I know the guy who created OpenBCI, and I was like, this is pretty cool. He invited me to their laboratory, which looks crazy, super cool. Actually, that picture I think is in their lab of the hand, and they have like 4 3D printers just printing away like headsets, and they have tons of computers and tons of headsets. But I went there and I started just like, okay, so how can I get the data? How can I know what I'm feeling? And whoa, just take a step back. They told me, this is what you're getting. It's just numbers. There's a long way to go. So I was like, I want to see what that way looks like. I got curious, and I've been doing it since. I've been a little bit of addicted to that. Oh, one more question there. Yes.
How much does the headset cost?
The last board that they released of 4 channels, which is completely Bluetooth and no dongle, is $199. The headset you would print yourself, or you can order there. I think it's another couple of a few $100. So there are ways. It's more affordable than 30K, and it should get cheaper as time passes because new techniques and improvement to the manufacturing process should help out.
What types of applications have you, like we've seen the hand, and what
Yeah.
did you build with the...
I developed a dashboard in Angular 2 where you can see your brainwaves in real time. I didn't show you that today because I didn't have the actual brainwave, the actual headset here. But this dashboard pretty much you can see your brainwaves in real time in different type of ways. You can see it in a frequency plot. You can also see it in the different ranges like beta wave and alpha wave and all that. So I've been able to visualize it in detail what that data looks like. I say, okay, I want to do something with this data, but I don't know about this data. I don't know what this looks like. So let me see if I can visualize it so I can now try to make sense of it. Yeah.
Did you also manage to visualize it in some sort of map on top of, for example, brain scan?
Brain scan?
Oh yeah, there are like visualizations that you can see from what area in the brain the waves come.
Yeah. So are you talking about an MRI here?
Yeah, for example. Or
Yeah. So
or you can see like for the occipital lobe or the temporal lobe, like
yeah.
places.
The OpenBCI people, they have what they call the GUI, which is based on processing, and they have a topo plot, which is like the view from above here, and you can see where the electricity is coming from, and whether it's like negative or positive. I'm still working on doing something like that, but I got sidetracked into doing like the libraries where people can also contribute. But there are ways to know what sensors. Now it gets very tricky because we're measuring the data in the scalp, and things that appear here could be coming from neurons down here. So it's very complex, but there are ways. All right, I'm going to leave it there because I think I'm out of time, and I want to be sensitive to Hugo, who's going to be speaking next. Thank you. Awesome. So I'm going to plug here.
All right.
Yeah. So we're going to have like a 5-minute break. You can grab a kind of beer, go to the toilet. Yeah, we'll be back in 5 minutes.
I need to use the restroom real quick.
Hep, you see me? Yeah, okay, cool. Are we live? Are we starting? Cool, okay.
Okay, we're gonna start again. We got the internet sorted. It broke. Hugo is here all the way over from his desk, just over there. Literally, he has come a long way to do his talk. The flight was very turbulent. He's going to give us a shout on NodeJS powered machines. He does wonders in the office. So it should be really interesting. A warm welcome to Hugo.
All right, yes, hi. My name is Hugo Wiledal. I'm a senior developer here at Majesty Amsterdam. I'm gonna talk to you about getting physical with NodeJS powered machines. So I'm gonna talk a little bit about myself, what are connected machines, Node.js and Jony 5, and I'm gonna show you some stuff that I've built with this technology, and then I'm gonna show you how to make one right in front of your very eyes. So I'm from the south of Sweden, actually from a place called Lund. South of Sweden is very flat. It's kind of like the Netherlands actually. It kind of looks like this. This is not far from where I was born. And it kind of looks like a discount Keukenhof, like if you move all the tulips and stuff. I was introduced to Flash by my father when I was 11. A very fantastic program. I started programming in ActionScript 2, was my favorite thing. It was just on the rise of the Flash mega culture, and it was amazing. I made some stupid Flash games and some Flash movies like this one. And 10 years later, and I landed a job here at Your Majesty. That's pretty good. So, what are connected machines? Well, some people call it like Internet of Things, or node bots is also another way of doing it. Usually when people say connected machines, they think of, or like Internet of Things, they think of like Philips Hue, the lights, and the Google Home, and all these things, like the Nest, what is a thermostat? Yeah. But I'm not going to talk about consumer electronics here. I'm going to talk about how to make your own connected things with using Node, web technologies, basically. What is the anatomy of a connected machine? Well, you need a brain, which is basically some kind of computer. Here we have some examples, like this is a chip, an Arduino, a Tesla, and a Raspberry Pi. These are all have their own different pros and cons, and you also need some code on there. Node.js, of course, with JavaScript is very easy to code and just put it on there, because this is actually Node.js based. These are all Linux computers, so you can just interface directly with Node.js inside of them. And you need your components. Like here's a servo, you can have webcams, this is a ultrasonic distance sensor, and you have your LED lights. Anything can be connected and disconnected as you please. So, most people, when they start doing things like this, connected machines, they use Raspberry Pis. It's very popular. It's about 40 euros if you want to buy it from the Netherlands. It's a Linux computer. It has Ethernet connection here. It has a USB, audio, video, onboard GPIO. GPIO stands for General Purpose Input Output. It's these pins here you see on the side. It basically allows you to connect components directly to the board itself and interface with them directly from code, which is pretty neat. Most people say this is the best option. I don't think so. I don't really like it, to be honest. Well, it's okay. It has a lot of support and a lot of people using it, so whenever you run into a problem, you can usually find a solution to fix it. But my favorite thing is actually the chip. The chip came out sometime last year, I think. It's a $9 computer. It's the cheapest computer ever created. It's a Linux computer, has onboard Wi-Fi, Bluetooth, audio, USB, video, and GPIO as well. Although these GPIOs are actually easier to plug in, because you can just plug things right into these holes here instead of pins sticking up. I'm not endorsed by Chip, by the way, but if you are, you can send me some stuff. When I do a project, this is usually what I use. Node.js, well, you already saw some Node.js or some JavaScript code before interfacing with Node.js, but I'm going to briefly explain what it is anyways. So Node.js is basically Chrome's JavaScript runtime running standalone. This is taken from the Wikipedia page. and it basically allows you to write JavaScript applications and run them from your desktop or your server or on a small device, Linux computer. It's powering a lot of microservices around the globe. Like we use it in-house for basically every project we do, whether it is inside of our assets pipeline or also for just hosting websites. It's used by major companies like Uber, PayPal, Medium, and Netflix. But it's not just for web stuff. Like you just saw with Alex showing you how to do EMG connections and stuff. You know, when apps were a big thing, well, they still are, I suppose, but when they were on the rise, people used to say like, oh, I really want to do X, and then you could say, oh, well, there's an app for that. Well, I think NodeJS is kind of the same thing, but for modules. Like Alex explained, he's doing an EMG module basically. So, oh, now something happened. Did we disconnect? No. That's fine. Well, but what? Oh, it's going again. Well, but basically, what you can say that with Node.js, if you say that, oh yeah, I wanna implement a arm thing to talk what pose I'm doing with my right arm. Well, there's a module for that basically. So Node.js is really wide. There's a lot of people making modules for it. And one of the modules that is being made is Johnny 5. Johnny 5 is a module that allows you to interact with Arduinos or anything that has basically different developer boards. You just connect it to your computer. Johnny 5 takes care of the serial connection and allows you to write applications really easily by using a basic library structure. I'm going to show you later how this works. Very cool. So I'm going to show you a little bit of the stuff that I've done with this technology over the years. Yeah, starting with GIF Booth Mark 1. This was a little booth that we made for an office party we had 2012. It was basically just an iMac connected to an Arduino. It was running a Flash application, which was still pretty cool at 2012 at the time. And I built this pedestal, which is actually the thing that we're using for our computers nowadays. And it actually has a hole in the here, so you can put the button on top here. And you just push the button and it would just record a GIF, and the GIFs would look something like this. It would overlap some cool memes from that time. And yeah, that was pretty neat. Party, Hillary Clinton, weird. Anyways, 2013 we decided to go a bit portable. So I built this little machine, which is basically a bunch of PVC pipes taped together with about a bunch of tape, and on top here we have two wooden boards with 5 cameras connected. They are connected to a Raspberry Pi 1, the first that came out, which is running a Python application with Pygame, I think is the library for game development. And it has its own power source in there as well, so you can just carry it around. And what it does is it basically takes 5 pictures at once and stitches them together, so it creates this matrix effect, or that was at least the point. You can see that I'm holding my phone here, and that's because the interface for the camera was kind of silly. It was actually a website that when you refresh the page, it would take pictures. So I'm actually just going around refreshing a Chrome tab and then taking pictures. And the result would be up and down, kind of cool sometimes. It depended, because as soon as one camera just fell down a little bit, it would be all glitching out and not very nice. But when it worked really well, and it was pretty cool. So yeah, the year after we still had office parties. We still needed a GIF booth. We made GIF booth Mark 2. This was a standalone little box. We found a shelf that we didn't use in the back of the office, so we just disassembled it, put it together as a box, put the button in the front, a camera at the top, a screen, and there we got a GIF booth. This one was a bit silly as well. It was made with 2 computers. This was the first time we used Node.js for this technology. So it has one mega computer, which we're now using as a streaming computer. Everything is reused. That's great. So this computer was actually has big graphics cards. It was displaying some heavy graphics on the screen. We had a little laptop inside that would be communicating with the big computer via socket connection. So when you push the button, the laptop would send it via socket connection to the big computer, and it would, yeah, it was kind of silly, but it really worked. People really enjoyed it, and they enjoyed it so much that they actually gave us a client product for this, for none other than Tommy Hilfiger. They wanted us to make a gift booth for them, so someone who had Tommy Hilfiger connections wanted us to make a gift booth for them. So we actually created one that they could put in the back of the show. So this was for 2015. They wanted to have the 2016 I don't know what they do, clothing thing showing. So they had this Titanic theme catwalk, basically, where you could see all the clothes that they were having that year. And they wanted to have a gift booth in the back where all the models got ready, so that they could, before they got out on the runway, they could pick up some props and just do some poses, and they can post it on Instagram and be all quirky and funny. So that was cool. We actually hosted everything on DigitalOcean, so that's really cool, all the stuff you're about to see. So this is kind of the result from that. You can see here basically the dressing room in the back here, and then all the makeup stuff is going. And yeah. This is Gigi Hadid. She was apparently a big model. I don't know. She was together with some guy from One Direction or something. I don't really know these people, but I was told it was a big deal, so I'm saying it. So that's pretty cool. Funny thing though, actually, when we were having this booth at the Tommy Hilfiger place, Tommy Hilfiger himself was walking around and checking out all the technology and stuff. And they were about to demo the booth for him. So basically how it worked was there was a big booth, a big TV and a screen and a camera. And there was a guy or someone standing next to it with an iPad. Pressing the iPad would trigger the booth, and a picture would be taken and uploaded. But when Tommy came around, it didn't work. And we had no idea why. And it turns out that Tommy had this entourage following him around everywhere. And basically what they did was they had stepped on the Wi-Fi router. So there was no connection, nothing worked, everything was broken. We found the router, plugged it in again, it was working again. But we didn't get a picture with Tommy, so that's a shame. But, yes, but so Johnny 5 can do a lot more than just buttons, of course. What I've showed you now is basically just a button interface that interacts with a screen and something happens. But you can do a lot more. There's more components than just buttons. And I'm going to show you some of that. This is a little thing I made last year. I call it Who Wants to Be a Drinkionaire, from basically the game show Who Wants to Be a Millionaire. So inside of this little box, we have a chip, the small thing you saw before. It's running a NodeJS application with a Koa, library, which is a HTTP library, so you can take web requests. And the website it's showing is this Who Wants to Be a Millionaire game, basically. And I had this little phone that was dedicated to put on this little box. And if you answer all the answers correctly, this little spout here will give you some shot. Basically, on the inside there was a tank with some random liquid that I would decide what it was. And you would get it. Yeah, you can see how it works. Oh, here, let's see, it works. works pretty well. It was pretty fun to make, and people having people interact with it. As you heard, there was also the main themes from the Who Wants to Be a Millionaire as well. Some German dude had copied them and put them up on his website, so I just downloaded them from there. It was great. Yeah, so it was using a drink dispenser, like a magic tap or something that you can just buy on Amazon for 10 euros or something. Let's see. My speaker notes disappeared. That's cool. Thank you very much for going full screen. Anyways, yeah. I also made this thing. I also made last year. Here at YM, we usually have, or Your Majesty, we usually have a gin vent calendar every December, where we basically, you're able to win a tiny bottle of gin if you're lucky enough. So what I made this little portable box with a chip inside, NodeJS, Johnny 5, you know, all the stuff. You know this already now. And basically it has this little display on top. And what it does, it just randomizes through a list of names, displays the name, and it can only display 4 characters, which is great for me because my name is Hugo. But yeah, so you can see here how that works. What's special about this one is also that it, when you turn it on, it connects to the Wi-Fi, and it downloads a list of names that I have on my server. So before you want to run the lottery, you can basically change the list of names. So that's pretty good. It also had a little bonus feature because we have a running joke.
To activate.
We have a running joke in the office, which is Toto Africa.
Toto mode.
So if you hold it in for 5 seconds, it plays Toto Africa. I don't know. In very low quality mode because the speaker was absolutely terrible. But it was, yeah, it's fun. Funny thing about this one was actually that my girlfriend asked me to bring this to her parents over Christmas. She lives in London, so but I thought that bringing this, something that looks like this on an airplane, would not be a fun experience for anyone, I think. So yeah, I did not do that. Here we have another one, automatic kettle putter honor and newsreader. This is something I made in an evening. I felt like, oh, in the morning I would like to hear the news and also have my tea brewed for me, basically. So I made this little thing, a little progressive web app that you can run from your computer or your phone. You just push a button and it will turn on the kettle and read me the news and weather information.
Okay. Good morning, Hugo. It's Friday the 23rd, 2016. It's 5 degrees and mostly cloudy out.
Yeah. I mean, this is pretty funny because, I mean, this kettle is not a smart kettle. It's a really dumb kettle. But I put a servo on this, like, just hot glued a servo to a piece of cardboard, and it basically physically turns on the switch when you press the button. That's one way of making it smart. Blind goggles. I made these goggles using, yeah, so here you can see the components all in the open. Basically this is the chip. I have an Arduino here connected with a USB connection. Here's a ultrasonic distance sensor, and it also has a pair of headphones coming out here and into my ear. So basically what it does, it pings a loud and obnoxious beep based on the distance that's in front of your head. So I can't see out of these, obviously, it's just a piece of cardboard. But so yeah, so I can actually walk around and I can hear where walls are because they go do 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 do. So that could be useful. I mean, if you're blind or something. And this is a little video of how I built it. This is version 2, you know, much flashier, more fashion, you know. Arduino, just hot glue, you know, it works pretty well, you know, it just sticks to anything. soundtrack. Cowboy Bebop. Just connecting the Bluetooth there, or YouTube, USB, sorry. And a portable power source there. And then I can hear from the... And here's me this morning trying it out. As you can see, you look absolutely fabulous with them on. Oh. I don't know. For some reason, I'm starting to. I always have ideas for how I can survive if I like accidentally survive a horrible accident or something. And this would, of course, cover me if I'm blind for some reason. Next stop is building some kind of arm if I lose one or something. But yeah. So those are examples. I'm gonna show you now how to actually make one with all the stuff that you've seen. So brace yourselves, because there's going to be some code on the screen, but from Alex's talk, you know it's going to be fine. So I hope you can see in the back. Anyways, you start with your empty machine JavaScript. It's just a JavaScript file. You import the nice Johnny 5 library, and we define a board. So just by doing new 5 board, Johnny 5 will automatically find any boards that are connected, so like an Arduino that's connected to your computer, running Firmata software on there. It will automatically connect it and set it up. We wait for the board to be ready, because it has to load some libraries and stuff. And then we set up a servo. So right now, if we have a servo connected to pin number 11, so the hole on the board that says 11, plug in the servo, now we can control the servo. We can set it to 90. So basically this server that I was using for this example is a server that goes from 0 to 180. So this will be in the center somewhere. And we can... Huh? To zoom in. I don't know. I'm sorry.
Never mind.
Sorry. Anyways. You add your COA, your server library, so here we can get some HTTP requests. We can define some routes. So now we can add a little counter. So we have a number, and every time you post to /press, we increase the number by 1. And then we can set an interval to basically set the server's position based on that number. And then all of a sudden we have a little fine machine. Let's try to actually see if this works in real life. Because here's one I prepared earlier. We're gonna see if this works. I have a webcam here so you can see it more closely. And I'm gonna actually connect this. Whoa. All right. So all the technology is working flawlessly today, so this is probably gonna work really well.
It's actually working really well.
Right now it's working okay. So I'm just gonna see here if I can get into my terminal, start this guy up. He's blinking, and all right. So if you would feel inclined, you can go to demo.go.cat, and you will see something there which you can interact with. And okay, let me just... Everyone got that? Demo.go.cat?
Yes.
Oh, hang on, let me just... Press button. Where is my... Where is the thing? It sounds like people are already pressing. That's good. Keep doing it. Let me just see if I can get the fucking... photo booth up. Oh shit, it's moving. Okay. I wanna show you this. I have a camera set up for this, so. Oh, but this is not the right camera. Oh, that's cool. Can I plug this in? Okay. So here we have this little dude. Oh yeah, that's very good. Is that working? Oh man. This is great. Okay.
Into balloon.
I will. Okay, there we go. Very nice. So as you can see, this is a little thing, which basically does exactly what you saw before. If you push this button, it will actually very slowly move. I've set it so it needs 1,500 presses. But it's actually moving pretty fast here. And as you can see, there's a little needle on the end here. So let's make this a little bit more interesting by adding something that can make noises. So here's a balloon. Let's see what happens if it... Yes. All right. So that was fun. Actually, let's try that one more time. I'm just going to go to my... This is admin stuff. Don't look at this. Okay. Yep. And then here we go. So now, press again. It slowly moves as we push the button. Let's just put this here.
I feel like your app needs multi-threading.
Oh yeah. Well, actually, the server is not very good. It doesn't have that many positions. It only has 180. Ooh. There it is. Cool. So, oh, okay. Someone reset it. Someone pushed the reset. I told you not to do that. All right. I'm gonna disconnect this before it goes well. All right. Here we go. So in conclusion, shut up. Okay. In conclusion, making machines, connected machines, is pretty easy. If you know how to make JavaScript, this was actually what Alex said before as well. If you know JavaScript and if you know NodeJS, just plugging things in and making it work is very simple. You just get your Johnny 5 library. Here's how you make a light blink, basically. It's very fun. You can make wacky things that pop balloons or glasses that that measure distance or things like this. Here's my friend using the screen with his nose after a few drinks. And just drinking directly from the spout. That works as well. And it's rewarding. Being a web developer, it's not often that I get to see my stuff being actually in the physical world. Most of the time it's always on screens or things like that, but actually having things moving in front of you is something special and magical about it. So yeah. Thanks for listening. Does anyone have any questions?
So Johnny 5 is a library, right?
Yeah.
Does it know only how to talk to Arduino, or is it very generic? What exactly can it do?
It's very generic, actually. It has a lot of things. Like if you have a Raspberry Pi, for example, there are third-party libraries that just interface directly with the GPIO on the Raspberry Pi, and also for the chip that I use. You can have a library that just plugs in the I/O basically. So Johnny 5 provides the language to talk to a servo and an LED light and stuff like that. But whatever connection you want to use, that's usually up to the third-party developers. And there's a lot of different ones, so you can use a lot of different boards. Yeah.
I have a question. Why do you use together chip and Arduino?
What?
You use the chip here?
Chip. Oh, this is not. No, so now I don't use a chip here.
Maybe somewhere else, like you using together
yeah.
chip and Arduino? Why not one of them? Okay, I would understand like if you use another chip, because it has also.
There's actually a technical explanation to that. So the question is why do I use a chip and Arduino when I can actually plug the component directly into the chip itself? Well, there's a technical explanation for the Who Wants to Be a Drinkionaire. I actually used just here it is. I actually used just the chip, no Arduino. The annoying thing was that that's a technical explanation. I had to route power from. So in here, there's this magic tap. The magic tap needs power from a battery pack to be able to operate its motor. Otherwise, the chip dies. So I needed to use a transistor in between. And to use the transistor, I needed a pull up pin or pull down pin. I can't remember. But the problem was that I needed to run my application in sudo to be able to use those pins, which was just a very stupid, annoying situation. So after that, I just used these because it's much quicker for me to do. Yeah, it's unnecessary, but yeah.
You would have solved it with a Raspberry Pi.
Sorry?
You would have solved it with a Raspberry Pi.
Yeah, you could have used the Raspberry Pi as well. But the chip is so much cheaper, that's the thing though. And it has Wi-Fi on board. But I guess the Raspberry Pi 3 also has Wi-Fi. But the rest...
I think in the end it's the same price.
Not if you buy it in Amsterdam, I think. I've looked around here and the Raspberry Pis are still like 40 euros. And you can buy 4 chips for that, so yeah. That's okay. Yeah, cool. Thank you, guys. And
That's great. Thank you, Hugo. Yeah, really fantastic talk. I really enjoyed it. Yeah, and we got it to stream perfectly as well. So that is good news. Yeah, so that is it for tonight. Yeah, pizzas should be here literally now. Hopefully the doorbell will ring. And then, yeah, I will throw them over there. In the meantime, there is plenty of beer and pizza. No pizza. Plenty of beer and soft drinks and wine over there, so you can munch through those. And yes, we are back next month with CodeInMotion speakers. So yeah, hopefully you enjoyed tonight. Hugo is about most of the evening.
Yep.
And yeah, if you want to serenade him with wine and questions, then feel free. And yeah, that's it. Thank you for coming.